Good morning, students. I am C. Radhakrishnan, Assistant Professor in CS Department, Community College of Engineering and Technology. Today, now we will discuss about authentication requirement and authentication functions. So, this is our today's we discussion about the authentication requirement and authentication functions of the public key cryptography concepts. So hash functions and digital signature concepts we are implementing. So what is the message authentication requirements? What are the requirements of in terms of MAC addressing? So message authentication concepts. First one, a disclosure. So disclosure means release the message content to any person or process or not processing appropriate cryptographic key. So you can perform the disclosure operations of this particular way. You can performing the release the content with the specific person, which is not appropriate cryptography with processing of cryptographic key. Next one, traffic analysis. The traffic analysis will define by discovery of the pattern of the traffic in between parties. So you can send the information from sender to receiver within the particular transmission time. We have in the traffic means we need to be before going to that whether traffic will be available or not. It should be verified and analysis will be made it up. After that only you can change the details to the receiver end. And similarly for masquerade. Masquerade means content modification of message. So insertion of messages into the network from fraudulent sources. So masquerade concepts also implemented requirements. So you can alert message will be implemented. And content modification. So content modification means nothing but changes to the content of the original message, including insertion, deletion, and transposition and modification process. So we are implementing for encryption process is nothing but we called as content modifications. Sequence modification. Sequence modification means way of flow, sending the sequential order. Instead of sequential order, we can send the different sequential methodology. So 1, 2, 3 means 1, 2, 3 is the sequential order means we just send it to 2, 1, 3 or 3, 1, 2, whatever it is. So any modification to the sequence of messages between parties, including insertion, deletion, and recording. So timing modification represents the delay or replay of the messages. We can define as timing modification. So suppose we are sent the data, we're waiting for the acknowledgement. So on particular time, within a particular time, the acknowledgement will be received, we can send the next data. Otherwise, some data will be possibilities of losing. So that again resend the previous message. That's why we are time modification will be implemented. And source reputations, that's denial of transmission of message by source. Suppose that we are need in position to retransmit the again source data into another one time. That's why we call as source reputations. And designation reputation, denial of receipt of message by the designations. These are all the major requirements of message authentication code. And message authentication functions we are represented in two-level function, that means lower level and higher level. In lower level, there must be some sort of functions that produce the authenticator. And the high level levels, user the lower level functions as a primitive in an authentication protocol that enables the receiver to verify the authenticity of a message. So generally we call it as three different functions: hash, message encryption, and message authentication code. Hash function, what is the meaning of hash function? Means a function that maps a message of any length into a fixed length hash value, which serves as an authenticator. So we are implementing a catch of n function. So catch of n is nothing but hash function of the original message. So that the function that maps a message of any length, it fixed length into a fixed length hash value. For example, hash value will be 10 means your hash value output will be 0 to 99. In terms of 1000 means 0 to 999. That is a hash index value. So based on the hash index value, the hash function will be implemented. Next one, message encryption. The message encryption is nothing but The ciphertext of the entire message serves as an authenticator. And next one, message authentication code. The message authentication code is nothing but a function of a message and a secret key that produces a fixed length value that serves as a authenticator. Next we will discuss about various basic machine encryption methodologies. Discuss about various basic message encryption process. So we will provide first symmetric encryption. From the symmetric encryption, we perform confidentiality and authentication. So your original message is encrypted with the key. The ciphertext will call as encryption of key with M. That will be represented here, center point. Just I will note it as in highlighting, find it out. That particular level, the encrypt will be implemented in the decryption in the destination side. The same key will be finally will get the target original plain text. So this is nothing but symmetric encryption. This particular concept will provide both confidentiality and authentications. Next, public key cryptography that will be provide confidentiality. Confidentiality, how it will be presented means this source A use the public key. The source A uses the public key of say receiver or destination B to encrypt the message M, and because only B has the value corresponding private key of B and only B can decrypt the original message. So this particular public key cryptography concepts, the encryption of the original message will be implemented with the help of designation public key. In the designation, corresponding private key will be decrypted. So the private key of the designation only known by the designation alone, so that it will be provided the confidentiality. Next one, public key encryption, both authentication and signature will be provided. How it will be provided means authentication and signature. It will be implemented with the original message will be converted into decrypted ciphertext with the help of encryption process. That particular encryption will be carried out with the original message, comma, center private key, the original message. From this original message, you can decrypt the original message in the designation end with the center public key. So automatically it will be provided the authentication and signature will be implemented. That is the concept of authentication with signature. That is our public key encryption concept. And third one, last one, public key encryption provide both encryption providing the confidentiality, authentication, signature. What is the information about related to confidentiality, authentication, encryption, decryption? The same key will be implemented for both encryption and decryption. So in our transmission, we require to provide the both confidentiality, authentication, and signature. We can implement the original message is encrypted with the private key of the center, and the particular message, encrypted message, again encrypted with public key of the receiver end. Finally, your original encrypted ciphertext will be transmitted over the medium. Once the transmitted medium which reaches to the original data, encrypted data to the destination level, in the destination, first decrypt the original message with center's private key. One ciphertext 1 will be generated. From the ciphertext, again decryption process will be carried out with the help of public key of the center. So automatically we will generate our original message. So the original message will be sent to the receiver end with the help of double encryption will be carried out. First encryption will be private key of the center, and second encryption is public key of receiver. In the destination level, first decrypt the process with private key of the receiver and again decrypt the message public key of the center. So automatically we will get the final result. So this particular level will provide the both confidentiality, authentication, and signature. So this is the way we are representing the message authentication mechanisms are implemented over the medium. It's about a requirement of MAC. So requirement of message authentication code. So taking into account the type of attacks, and MAC need to satisfying the following. First one, the first requirement deals with the message replacement attack, in which an opponent is able to construct a new message to match a given MAC, even though the opponent does not know that, does not learn the key. That is a first requirement. So automatically the opponent will not to learn and will not be known by their keys and their message. That is first requirement. Second requirement is the deals with the need to throughout a brute force attack based on chosen plain text. And final requirement detached that the authentication algorithm should not be weaker with respect to certain parts or bits of the message than others. These are all the major three requirements of MAC. Next one, some internal and external error control in terms of message authentication code. So internal errors possibility control mechanisms. Now, this particular first diagram, the first part should purely for sender and second part purely for destination. The source original message is combined together with the performing the values of F. Here F is nothing but the value of the source, and the message will be directly connected with the fixed length of size. So the hash function, that means here we implemented the message authentication code. The function C value is called as MAC function. Here F is represented as MAC function, which is calculated the MAC value transmit to the receiver end. The receiver perform the same calculation at the receiver end. So received MAC is compared with calculated MAC. So receiver MAC is calculated with calculated MAC. If both are matches, then the receiver is assured that the message does not be altered, and the receiver assured that the message is from the aligned center. If the message include a sequence number, and the receiver can assumed that a proper sequence, because the attacker cannot successfully alert the message. The images will be shown here. So your original message M and concatenate with their some fixed length of their MAC code is combined together, send it to the message with their fixed length of M message, and it will be encrypted with key value. It is concatenate with the center to the receiver end with their encrypted format. So encryption of key comma M concatenate with F of M. This particular concatenation procedures, everything will be again perform the same calculation in the receiver end. So first decrypt the original message, and M of F of M will be calculated. It will be taken as a fixed size separately, and the original message fixed length will be separately, and the original message is combined together. Both original message, the sender and the receiving message, both are all same. It will be equal. Similarly, for external error is possibility for that. So for that purpose, we are implementing for these are all internal levels. In terms of external, the original message is encrypted with the key, that is encrypted message. This encrypted message is concatenated with fixed length. In the internal part, your original message will be converted into fixed length. Here, in the external error control mechanism, the encrypted message is converted into fixed length and is combined with concatenate with their encrypted message. You transmit it to your sender side. The sender receiving the message, the received message will be decrypted with the original message, and as well as we have to perform the from the recipient, the fixed length will be compared with their original message. It will be compared, both are all same, means there is no in the attacking in the external level. If it is mismatched, means some external having some other attacks are also possible. It is a way to identifying their error control mechanisms in MAC values. So that's all about our requirement of MAC authentication requirements and authentication functions, and MAC requirements and their functions. That's all about the concept. Next, we will discuss about the next topic in the next video. Thank you. Thank you, students.